All right, Chapter 4, we're going to be studying trigonometric functions. There are several different objectives, but there are three main objectives here that we're going to do. We're going to use trigonometric functions to solve right triangles. Secondly, we're going to find values of trigonometric functions for any angle. And thirdly, we're going to graph trig and inverse trig functions. So those are the three main areas that we're going to study in trigonometry. Trig, as you can probably figure out from the word itself, is we're going to be studying the measures of triangles, so both side angles and angle measures. In our first lesson, 4.1, there are primarily two things that we're going to look at, and one of them is to find the values of trig functions for acute angles of right triangles, and the second thing is to use that information to help us solve right triangles. So the first thing is getting comfortable and acclimated with the trigonometric functions and the definitions of a trig function and the triangles, and then we're going to use that information to help us solve right triangles. So here's the first part of our objective. We're going to find the values of trig functions for acute angles of right triangles. In this first key concept, what they're going to show you are the definitions that we're going to be using to solve these right triangles. And some of these you're very familiar with. You've studied SOHCAHTOA once before, at least once before. So SOHCAHTOA is an acronym that helps us remember the sine, cosine, and tangent. We're going to add on three new ones, and that is the cosecant, secant, and cotangent. So first thing is getting comfortable and getting these things memorized and knowing what they're asking whenever they ask for a tangent or a cotangent, secant or cosecant. Getting those ideas locked in your mind is just a basic idea of getting these memorized as far as what they're looking for. So just a quick review here. The value of a trig ratio. Trigonometry means triangle measure, so we're going to be finding angles and lengths of sides in a triangle. Although this lesson is going to be specifically for right triangle trigonometry, we also have means to study triangle angles and side measures when we do not have a right triangle. That'll be a little bit later on in the unit. So typically what we do is we use the Greek letter theta to help us find to represent or to designate the area angle that we're trying to find the ratios of. So I'm not going to go through a whole lot of this. I'm sure we're pretty familiar with these, but don't forget to look at your cosecant, which is really abbreviated as CSC. The cosecant is the reciprocal of your sine function. So if you look at the sine function, it is opposite over hypotenuse. The cosecant is the hypotenuse over opposite. So it gets reciprocated or flipped upside down. And that same relationship occurs with the cosine and the secant. The cosine and secant are closely related because the secant is the reciprocal. If you look at the definition, cosine we have memorized as adjacent for hypotenuse, but the secant reciprocates that, or flips it upside down, and we have hypotenuse over adjacent. Same ratio and same relationship between a tangent and a cotangent. The cotangent is simply the reciprocal of your tangent function. So tangent is opposite over adjacent, so that means our cotangent must be adjacent over opposite. They also explain some of those reciprocal functions down here in the same kind of idea. The cosecant is 1 over the sine of theta. The secant of theta is 1 over cosine of theta. And the cotangent of theta is 1 over tangent of theta. So we're going to expound on those ideas in just a second here. First thing I'm going to do, I'm going to get this board realigned in the position that I need it to be in. Okay, what I want to do is take a look at one of these reciprocal identities, and you can do the same thing with all the others, but show you just kind of the idea behind this cosecant of theta is equal to 1 over sine of theta. It's called a reciprocal function. Reciprocal means we're going to flip it upside down, but here's their definition. We'll start working with it. So the cosecant of theta is equal to 1 over sine of theta. What I'm going to do is I'm going to do a replacement. I'm going to replace or substitute for sine of theta what sine of theta is defined to be. And the sine of theta, by definition, is the opposite over hypotenuse. So I'm going to replace that with the opposite over hypotenuse concept. It is the opposite side divided by the hypotenuse. And then we get a complex fraction. A lot of times we're not real happy or excited to see a complex fraction, but when we have a complex fraction, what we can do is we can think of our main fraction bar as a division bar. So this really is saying we have a 1 divided by the opposite over the hypotenuse side lengths. A division can be turned into multiplication or times the reciprocal, which is the hypotenuse over the opposite. And 1 times anything is that thing, so I think I just did correct that. Spelling hypotenuse over opposite. So 1 times anything is the same thing, so we have hypotenuse divided by opposite, and that is how they define cosecant of theta. So on every one of these, we can apply the same strategy to help us figure out how they are defining the cosecants to be the reciprocal function. So this is just one example that I showed you here, how the cosecant is defined to be the reciprocal of 1 over sine. Since sine is the opposite of hypotenuse, if we reciprocate and multiply, we end up with this definition that whenever they ask us for the cosecant of an angle, we always want to go and grab the hypotenuse side length and divide it by the opposite side length, and that's how it's defined. There's also another one in here that I want to go through, and they have you do it later in the exercise, but I'll give you a little plug on it here right away. And it's whether we define the tangent or the cotangent function using the values of sine and cosine. So they have defined tangent of theta to be the sine of theta over the cosine of theta. Now they also have tangent defined to be, early in our definitions, as the opposite over the adjacent. Now these two ideas are going to be connected together here, and that's what I'm going to show you on how we can apply some of these same kind of concepts and strategies. So the tangent of theta is equal to, well, I'm going to replace the sine of theta with, sine of theta is the opposite value for side length over the hypotenuse length, divided by, and the cosine, I'm going to replace it with what the cosine is defined to be, and that is the adjacent side length over the hypotenuse. And once again, we get this idea, or this complex fraction that we're going to work with. Now this time I'm going to use this as my main fraction bar, which is a division sign. So really it's the same thing as taking the opposite side length number divided by hypotenuse number. We're going to divide it by the adjacent over the hypotenuse. But division is the same thing as multiplying by the reciprocal. So if we apply the concept of division of fractions, and we multiply by the reciprocals, and what we can see is that if we do our simplifications, the hypotenuses will reduce, and what we're left with is our opposite over adjacent. So this is one way that the tangent of theta can be thought of. And the other way is what we start off with, is that the tangent of theta can also be thought of as a sine of theta over cosine theta. So these are equivalent values or equivalencies between the ways that we can write tangent. And this is going to come back into play later on when we do trig identities, so part of this is just kind of getting you prepared for what's to come. So we've got some basic definitions of tangent, cosine, sine, cosecant, secant, and cotangent. Also some reciprocal identities, and what I call these are your basic building blocks from sine and cosine. So with that I'm going to stop, then we'll go into the next video and we'll start looking at some examples of things you're asked to do.